continue our lecture on fixed income. To be more specific, on bond. We basically started, I think we basically started interest rate risk. So let me go to the correct slide. Okay. So I pretty much finished this page, right? So this 6 features or 6 results about interest rate risk. Basically, there are 2 ways to understand these results. First, which is a simpler way, you could just use this nice picture, right? And you could just compare these different bonds, and then you will get these 6 observations. And second, which is a little harder, you could think about intuition, right? Why a certain observation is correct. Okay, now let's move on to talk about realized return. As a bond investor, clearly you should not only care about the theoretical results about bond returns. More importantly, you would actually care about realized return, right? That is, at the end of the day, by investing, let's say, $1,000, by the end of the day, how much money in the end, as an investor, you would get. You would care about this, right? So we're essentially thinking about realized return. Now, the first obvious question you could ask is, let's say if I have a bond which has a yield of 8%. Now, if I hold this bond, let's say this is a 10-year bond. Let's say I hold this bond for 2 years. What is my realized return? Will I get 8%? Well, the answer is generally it is not true. You will generally not get 8% return, even if the bond has a yield of 8%. Why? The reason is because of there are actually 2 important reasons. The first is default risk. We have talked about default risk, right? Because, well, maybe, let's say you won't hold it for 2 years. Maybe at the end of the first year, the firm will default. You will not get your coupon payments. In this case, your realized return will definitely be lower compared with promised returns, right? This is the first perspective. The second perspective, which is today's focus, is about interest rate risk. We have learned about this. Basically, a very basic result is if interest rate increases, bond price will decrease. And as an investor, you will suffer, right? So this is basically the first type of interest rate risk, which is the price risk. That is, as a bond investor, if I want to sell my bond at the end of the first year. Now, my concern is maybe the interest rate will be higher at the end of the year. In that case, my bond price will be lower. So my return will be decreased because of this price risk. Then a second type of risk, which is more subtle, is about reinvestment risk. So if you have a bond which pays coupon payments, now you have to reinvest those coupon payments to generate returns, right? Think about this. Let's say you hold a bond for 5 years. Let's say this bond pays you coupon payments every 6 months. So you can imagine that during the 4 years of investment horizon, you will get 10 coupon payments every time you get cash. Now you have to think about how would I invest my coupon payments, right? Even this bond promises you 8% yield. When you get your coupon payments, the market interest could be different. For example, if the bond promises you 8% yield, but after 2 years, the interest rate changes to 6%, and when you're investing your coupon payments, the best return you can get is 6%, right? So in this case, you can see that reinvestment risk essentially means when you're reinvesting your coupon payments, potentially you will get lower returns. Right? And we can think about how these two risks will be related to your investment horizon. Let's say if you hold your bond until maturity, then you can imagine that because you're doing this, there is no price risk. You will only suffer from reinvestment risk. But if you're not holding your bond to maturity, let's say you have a 30-year bond and you will sell it after 10 years. In this case, generally, you will have to face two kinds of risks. You could suffer from the price risk after 10 years, and you will definitely face this reinvestment risks. Okay, now let's use examples to understand these two kinds of risks. So let's say you're having a 30-year bond, right? And this annual coupon is 80%. So I guess we're assuming you're having annual coupon payments, and the par value is $1,000, and the yield of the bond is 8%. So we have learned about this, right? So basically you can see here the coupon rate is 8%, which equals yield. And we learned about this. If coupon rate equals yield, then the bond price will be at par. That is, the bond price will be $1,000. Right. So let's see some different cases. Let's say if the yield remains at 8% over the year, then the bond price will remain at par because coupon rate equals yield. So the holding period will be 8%, right? So basically there are first the case, that is the yield would be 8%. So the yield would be 8% after 1 year. Right? Now in this case, what is your holding period return? Right? Holding period return basically means your realized return for this holding period. Here we have this 1 year holding period. Right? So if bond yield stays at 8% after 1 year, your return would be 1,000. And after 1 year, you will get $80 of the coupon payment. And the bond price stays at 1,000 and minus the initial price. So this gives you 8%. That is, in this case, your realized return equals yield. Now let's look at the second result. The second case. Let's say if the yield falls below 8%, right? So yield falls below 8%. Now after 1 year, let's assume because yield falls, the price increases to 1,050. So you will still get your 80%. So you will still get your $80 of coupon payment, and the price would increase to $1,050 divided by 1,000. This gives you 13%. Clearly, you can see that in this case, price risk becomes price benefit because yield decreases. And the only difference in these two calculations is about this final selling price of your bond, right? And you could have different bond price when you're selling the bond because you could face different levels of interest rates when you're selling the bond, right? Okay, great. Okay, now let's look at reinvestment risk. This one is actually pretty easy to understand because we're only having a 2-year bound. So everything is very clear here. Let's consider a 2-year bound setting at par, and it has a 10% coupon rate. And we also assume the coupon is paid annually, and the yield is 10%. Right? So it's a 2-year bound, 10% coupon rate, and annual payment yield is 10%. So let's consider 2 cases, right? In these 2 cases, the yield of the bond will actually stay the same. But the difference is the interest rate at which the coupon payment can be invested is different. In the first case, let's look at the cash flow here. So on day 1, you will get $100 of coupon payment, right? So this is your coupon payment. So it's basically 10% times 1,000 par value. And on the date when you receive your coupon, you will reinvest your coupon payment. And we assume the reinvestment interest rate is 10%. So after 1 year, this $100 will become $110. Very easy calculation. And then on day 2, or at the end of the 2nd year, you will get 1,000 par value and you will get your coupon payment. So you will get $1,100, right? So basically you can see that the total or the future value of your bond when it matures is $1,210. Now let's look at the second case. Here we have a different reinvestment rate, 8%, right? So in this case, still you will have $100 of coupon payment. However, you will invest this coupon payment at a lower price. So in this case, you can see that you will have $108, and still you will get back your principal and 1 coupon payment at the end of the 2nd year. So it's $1,100. In this case, you can see that because of the difference in the reinvestment interest rates, you will have a lower return in the second case. Right? To be more specific, in the first case, you will get 10%, which is the same as the yield, because in this case, the reinvestment rate is 10%. In the second case, your realized return is actually smaller than the yield. This is because your reinvestment return suffers. It is lower compared with 10% return. So in the end, you will only get 9.91%. Clearly, if you look at this case, for this example, we are purely thinking about the price risk. And in this second example, because you're holding your bond until maturity date, so there's no price risk. In this case, you will only suffer from the reinvestment risk. Okay, now let's see this example. Okay, so this example is the more complicated one compared with the previous 2 examples because it considers a more realistic case. It considers both price risk and reinvestment risk. Okay, let's see how this problem works. Let's say you have a 30-year coupon bond, and coupon rate is 7.5%, and you will also get annual payment. Of course, this is for simplicity. And the price of the bond was $980. The yield is 7.97. So actually don't need this $880 because given 30 years, right? Given annual payment, given the coupon rate and yield to maturity, you should be able to find out the price of the bond is $980. And you plan to hold it for 20 years, right? So if you draw a timeline here, let me draw a timeline here. If you draw a timeline, it's a 30-year bond, and you will sell at the end of the 20 year. This basically means when you're selling your bond after 20 years, you will suffer from price risk, right? Because the yield at the end of the 20th year is uncertain. Now you forecast that the reinvestment rate on the coupon bonds will be 6%, right? So here you can see that you're suffering from this reinvestment risk. So basically your bond has a yield of 7.67 and your coupon payments have a coupon rate of 7.5. However, when you're reinvesting your coupon payments, you will have a lower return, which is only 6%. And the bond yield to return will be 8% when it is sold. So basically, this tells you there will be price risk, 8% for this yield. At the end of your investment horizon, the bond will have 10 years remaining. So if you want to calculate your return, the first step is you want to ask, what is your selling price, right? What is your selling price after 20 years? So this is the basic question you have to ask. What is your selling price here, right? Let's call your selling price after 20 years as P20, right? What is your selling price? And you also want to know what is the future value of your 20 coupon payments reinvested at 6% interest, right? So the 20 coupon payments can be considered as a 20-year annuity with annual payment of $75, right? So you can see that the problem has already given you answers. So it's 2,758.92. And this basically means after 20 years, the P20, the price, your selling price is 699.45. And you will also think about your reinvestment returns, right? So you will also have the coupon payments reinvested at 6% rate. So this one is 275892. Basically, this is the total payment. This is the total payment you will get after 20 years, right? So now let's say we want to think about what is your annual return, right? So your annual return is given by the price of the initial price of the bond, which is $980. And let's use R to denote your annualized return. So it's 1 plus R with this exponential of 20 because you have 20 years. And this is the final date value, which is 966.45 plus 2758.98. So this solves R equals 6.9%. Obviously, this is smaller compared with the promised yield, right? It's smaller than 7.67% because you suffered from both types of risk. You're suffering from price risk because the yield increased to 8%, so you will sell your bond at a lower price. And also the reinvestment rate was only 6%. So you reinvested all your coupon payments at a lower rate compared with yield. Another thing is you might wonder, hey, how do I get these two values, right? How do I get this 966.45, and how do I get this 2758.92? So basically, you can see that this is about using, let's say this is just about using financial calculator, right, to solve what is the bound price and what is the future value of annuity. So let me again use the financial calculator and show you how to solve these two numbers. Okay, let's find out the first value. That is this 966.45. So, okay, we have 1,000 future value, and we have annual coupon payment of $75, and we have a yield of 8%, right? Because we're looking at the bound price after 20 years. And we assume after 20 years, the yield would be 8%. So we have a yield of 8%. And we have 10 years left. So let's compute the present value. Okay, now we're having this same answer, right? $966.45. Now let's see how would we calculate the annuity, right? We have 20 coupon payments reinvested at interest rate of 6%, and the annual payment would be $75, right? The process is quite similar to calculating bound. However, here we're looking at the future value of these 20 coupon payments, right? So basically, we will set the present value as 0. Now let's start. Okay, so per year payment would be $75, and the present value is setting at 0, and annual interest rate would be 6%, and we have 20 coupon payments, right? 20 periods, so we have 20. And now let's compute future value, right? So here the future value is 2758.9193, which is the same as the lecture note answer. Okay, that's great. Again, you could do some practice, right, to learn how to use the calculator to calculate these future values, present values, and calculate bound yield. Of course, maybe you have already become an expert on this, then that's even better, right? Okay. Let me see. Okay, let's start. Let's proceed to the next page. So let me summarize the relationship between realized return and interest rate risk. So basically, if interest rate changes, there are two kinds of risks. The first is price risk. Essentially, it means that if yield increases, and we would know that the bound price will decrease. And we have learned different factors, right? We have learned what kind of factors could affect this price risk. For example, we learned if a bond has a longer maturity, then it suffers more from this price risk. And we know that if the yield of the bond is higher, then the bond would suffer less from this price risk. And the second type of risk is reinvestment risk. It basically means that after getting your coupon payments, you could potentially reinvest your coupon payments at a lower rate compared with the bond yield. And this type of reinvestment risk increases with maturity, right? And it increases with coupon rate. Now, why? Why reinvestment risk increases with maturity, right? Well, this is fairly intuitive, right? If the bond has a longer maturity, then it means that you will have a lot of coupon payments, right? Let's say if you have a semi-annual coupon payment span with 30-year maturity, you will have 60 coupon payments. So of course, all of these 60 coupon payments will subject to the reinvestment risks, right? And the investment risk also increases with coupon rate. This is also easy to understand. If your bond has higher coupon rate, this means you will have larger coupon payments. If you have more higher coupon payments, then this implies you will have higher risk from this reinvestment risk, right? And you could also see that, interestingly, these two kinds of risks offset with each other. Basically, if the interest rate increases, right, then you can see that bond price will be lower. However, if interest rate increases, the coupon payment or the reinvestment returns of these coupon payments will actually increase because now you could reinvest at a higher rate. Okay, now let's talk about duration. Duration is actually very much closely related to maturity. Why do we want to understand duration? Well, because we want to understand, again, interest rate risk. And duration is a measure which gives us a clear understanding on how bond price will change if interest rate changes. So let's start from a very simple example. And we actually have discussed examples like this before. So let's say we are looking at two kinds of bonds. The first one is a coupon bond with 8% coupon rate. The second is a zero coupon bond. Right? Now what we want to look at here is we want to see how bond price will change if interest rate changes. Of course, this is a table which could give you a lot of thoughts. Here, let's just focus on one specific aspect. That is, we want to compare these two bonds, right? So let's say if both bonds have maturity of 1 year, and under both cases, bond yield increases from 8% to 9%, right? 8% to 9%. We know that if yield increases, bond price decreases. Now let's compare the percentage in bond price decrease, right, across these two bonds. For this, the first table, the table on the top, gives you the case for this 8% coupon bond. Here, what you can see here is the bond price falls by 0.94%. And the bond price for the zero coupon bond falls by 0.96%. So this basically means as yield increases, zero coupon bond price falls by a large percentage. Right? This will be even more obvious in the case of 20-year maturity. So let's say you're having this 20-year maturity here. And again, we're looking at the percentage change in price. So you can see that for this 8% coupon bond, its price change is 9.2%. And for this zero coupon bond, its price change is 7.46%. It's almost twice the change of the 8% coupon bond, right? Now, what kind of results you can draw from these comparisons? So the observation here is we know that if a bond has a longer maturity, then it will suffer more from interest rate risk. That is, if a bond has a longer maturity, its bond price will decrease more if interest rate increases. So here you can see that This zero coupon bond, its price decreases more if interest rate increases. So this basically implies that it's as if the zero coupon bond has a longer maturity compared with the 8% coupon bond, right? But then you could say, hey, wait a minute. You have told us both of these two bonds, they have the same maturities, right? They have 1 year, 10 year, and 20 years. But now why you're saying that this zero coupon bond as if has a longer maturity, right? Well, the reason is because the maturity defined here is really not the best measure to think about how bond price will change with interest rate. So that's why we want to think about duration. Now, before formally defining duration, let's think why maturity is not the best measure to think how bond price will change if interest rate changes. So let me draw. Okay, so basically we are having a Okay, let's think about 10-year coupon bond versus a 10-year zero coupon bond, right? So let's say we are thinking about, so this is a 10-year coupon bond. 10 year is just too long. Let me use 2-year coupon bond as a simpler example. And this is a 2-year zero coupon bond. So let's say this is year 2. Now, what you can see here is the second bond is a zero coupon bond. So you will only get a cash flow here, right? So let's write this as cash flow. What about the 2-year coupon bond? Well, you will have 4 cash flows, right? So you have the cash flow here, which is your first coupon payment. Okay. And the second cash flow, which is your second coupon payment. And the third cash flow, which is your third coupon payment. And now you will have fourth cash flow, which is your fourth coupon payment plus your par value or principal. Now, if you think about maturity, a more accurate measure is about maturity of these cash flows, right? So, okay, let me use a different color. So for this cash flow, right, its maturity is 2 years, right? Interestingly, what about this guy? What is the first cash flow's maturity? It's actually 6 months, right? What about this guy? Well, you guessed it right, it's 1 year. This guy is 1 year and 6 months. And this guy, it's 2 years, right? So this gives you an idea that the effective maturity of the 2-year coupon bond is actually lower compared with the 2-year zero bond. The reason is because for this 2-year coupon bond, it has coupon payments. And these coupon payments, they have lower maturity compared with this zero coupon bond. So the average maturity of the 2-year coupon bond is smaller than 2 years, right? Okay. Let me summarize this insight here. It's pretty important. Now let's summarize why the 20-year 8% bond has lower effective maturity compared with the zero coupon bond. The reason is because this 20-year 8% bond makes many coupon payments. And each of these coupon payments have their own maturities. So basically the 20-year 8% bond is actually a portfolio of coupon payments. So the effective maturity of the bond should be the average of the maturity of these coupon payments, right? And for the zero coupon bond, it makes only one payment on this maturity date. So its maturity, or its effective maturity, is essentially its defined maturity, right? So this leads us to define duration. What is a duration? It's really the average maturity, right? In essence, it's just average maturity. Now, how do you do the average? Here we will use the weighted average. So essentially, duration is the weighted average of maturity for each coupon payment and for the principal payment. Now, what is the weight? Well, because we're thinking about weighted average, we have to figure out what kind of weight do we want to use, right? The weight is defined by the present value of each cash flow divided by the bond price, right? So in terms of formula, duration equals the weighted average of different maturities for different cash flows, right? So here, this T refers to maturity. This WT refers to weight, right? For cash flow, not cash flow. Weight for maturity T. Now, how do you calculate the weight? So weight is calculated by the present value of the cash flow at maturity T divided by bond price P, right? I can understand now this calculation of duration seems a little abstract, right? So you will see a example which tells you how to calculate maturity which tells you how to calculate duration. And you will see that it's actually fairly simple. Okay, why do we want to talk about duration? Well, because first we have talked about this. It is a more accurate measure of the effective maturity of the bond, right? The second is it will give you a nice formula, right? This formula tells you how a bond price will change if interest rate changes, right? So let's talk about the second benefit, right? Let's talk about why it is a measure of the interest rate sensitivity of the bond. So here we have this formula here. The left-hand side, delta P divided by P. This basically gives you the percent change, right? Percentage change So this is the percentage change in bond price, right? And what is D here? D here is just duration. So this is duration. What is Y? Y here is the yield, right? This delta basically means change, right? So you can say that this formula basically says that change in bond price divided by bond price, which is the percentage change in bond price, equals minus duration times the change of 1 plus yield divided by 1 plus yield. And you can see that this formula can be simplified. So we could define the so-called modified duration, which is essentially duration divided by 1 plus yield. So if we use modified duration, then we could see that the percentage change in the bond price equals minus sign modified duration times the change in bond yield, right? So this is a nice clean formula And you can see that it tells you that if there's a change in the bond yield, how the bond price will change in percentage term, right? So it's a very nice formula. Now let's see this example here and learn how to calculate duration and how to use this formula to understand how bond price will change with respect to interest rate changes. So let's say we're having a 2-year bond. Oops. So we're having a 2-year bond with a par value of 1,000, 8% coupon rate, and 10% yield. Now assume initially the yield was 10%, and now it increased from 10% to 10.02%. We assume we have annual coupon payments. Now, what is the initial bond price? What is the duration? And what is the percentage change in bond price if annual interest rate increases from 10% to 10.02%? The first question is actually pretty simple, right? About initial bond price. Obviously, you could use your calculator. But here, because we're having a 2-year bond, so let's just use the hand calculation, right? Because that gives us the chance to actually use the formula. So let's look at the first question, right? Bond price. So bond price equals the discounted cash flow of this bond. And we have annual coupon payment. So the first cash flow is 80 divided by 10% interest rate. And then on the last day, you will have $1,000 principal and $80 coupon payment. And because it's at the end of this second year, so you would use 1 plus yield squared. So this gives us 965.29. So this is the bond price. Now, what is the duration? Finally, let's calculate the duration here. Now, duration is the weighted average of time to maturity for different cash flows. Now, for this first cash flow, right? For this guy, for this $80 cash flow, its time to maturity is 1 year, right? So we have this 1 here. And for this second cash flow, for this $1,080 cash flow, its time to maturity is 2 years, right? And now we have to use weighted average. And the weight is calculated by the present value of the cash flow divided by the bond price, right? So you can see that here the present value of the cash flow is given by $80 divided by 1.1. And bond price, it's here, right? 965.29, right? And now the weight is 1080 divided by 1.1 squared. This is the present value of the second cash flow. And divided by 96529, right? Very simple. And now this gives you 1.925. Again, let me explain this calculation for the second time, right? So here you have time to maturity for each. Okay, this is bad idea. It just looks bad. So this case, this one is the time to maturity for the first cash flow. Time to maturity for the second cash flow. Obviously, this is bond price, right? And these are two present values for the two cash flows, right? And present values divided by the bond price, you have the weight, right? Okay, great. Now let's answer the second question. What is the percentage change in bond price? So we want to look at bond price. What do we do here? We will just use this formula here, right? So according to this formula, equals minus modified duration times the change in yield. Now modified duration equals duration divided by 1 plus yield and times the change in yield, which is 1.925. And here you would use the original yield, right? You should use the 10% yield. Don't use the 10.02% yield. And the change in yield is 0.02%. So this gives us, let me see, minus 0.035%. Right? So you can see that if you want to answer how bond price will change if interest rate changes, it looks like this is actually a very complicated problem, right? Because you could imagine that if you use the original bond price formula, it could become complicated. But here you can see that through this very simple definition of duration, and then through this very simple calculation here, this very simple formula, we could quickly show that if bond price increases by 0.2%, if the yield increases by 0.2%, bond price will decrease by 0.35%, right? Okay, that's the simpler case. That's the case if you have annual coupon payments. Now let me make your life a little harder. Let's think about the more complicated case. So let's say we are looking at a case which is more realistic. Let's say you're having this semi-annual coupon payments. And first, what is the initial bond price? What is the duration? What is the percentage change in bond price? I will not redo this calculation here, so I will just show you the answer here. You can see that I'm not using the calculator to find out the bond price. What I'm doing here is I am discounting all these cash flows, right? Basically, it's a 2-year coupon. It's a 2-year bond. And coupon is paid every 6 months. So this is a case, you have 4 cash flows. So you basically have these 4 cash flows. And we have learned whenever you're having this semi-annual coupon payment, you have to use this 6-month yield, right? If the annual yield is 10%, then the 6-month yield would be 5%. So that's why you would discount these cash flows at 1.05, right? So this gives us a number of 964.54. Okay, so price equals 964.54. Now the second question is about what is the duration, right? Again, I will not repeat the process. I will just show you the answer here. Now, we have 4 different cash flows. And first cash flow has a duration of 0.5. Second cash flow, 1 year. Third cash flow, 1 year and 6 months. Fourth cash flow, 2 years. And now we have to calculate the weighted average. And the weighted is calculated by the present value of cash flows divided by the bond price. So you can see here, this is the present value of the first cash flow. And this is the present value of the second cash flow. You could do the same for the third cash flow and fourth cash flow. And then you would divide by bond price. This gives you weights. Right? And in the end, we have 1.885. 1.885. Now, what is the percentage change in bond price? Now, we will use the same formula, right? So bond price change equals minus modified duration times change in Y. Now, a caveat here is this Y is not the change in annual yield, right? Because you're having semi-annual coupon payment. So you should actually use this or calculate this delta Y as the change in 6-month yield, right? And another caveat is about calculating this modified duration. So let me write this as d divided by 1 plus y delta y. Now, if this y is 6-month yield, then this d should be modified, right? Well, what is this d here? This d means the duration is 1.885 years. However, we are using this 6-month as one period. So we should modify this d as 1.885 times 2, right? So basically it's like you're saying that you have 1.885 times 2 half-year periods, right? And now 1 plus y, which is 5%, right? Because we're using 6-month yield. And the change in y is just 0.1%, right? The reason is because when you're looking at annual yield, it increases from 10% to 10.02%. And if you're thinking about the 6-month yield, the change, right, it's just the half of the annual change, which is just 0.01%. So this gives us, this gives us minus 0.3591%, right? And if you compare these two problems, you can see that you actually have different numbers, right? So for example, you can see that the duration here is 1.925 if you're having this annual coupon payment. And if you have semi-annual coupon payment, the duration is 1.885. Obviously, this tells you that when you're calculating duration, you have to make sure whether this coupon is paid annually or semi-annually. Okay, now let's look at several different results or claims on duration. First, the duration of a zero coupon bond equals its maturity. Well, this is like obvious, right? Because it's a zero coupon bond. So you don't have any cash flows before its maturity date. In this case, duration equals maturity. Second, a bond's duration is higher when the coupon rate is lower, right? So why? What's the okay, first let's just look at the picture here, right? Get some example and see how you could draw these results from this picture here. So here you can see that we have 4 different bonds, right? We have 0 coupon bond, and then we have 3 coupon bonds. If you look at this line, it basically gives you the first result. That is, duration of a 0 coupon bond equals its maturity, right? You can see that let's say if the maturity is 10, then duration is also 10, right? Oops. Okay, let's look at the second result. Second result says a bond's duration is higher when the coupon rate is lower, right? So if you look at these two guys, right? These two coupon bonds, they have the same yield. However, you can see that the bond with 3% coupon rate actually has larger duration. That is, this guy has larger duration, right? So what's the intuition for this? Well, think about this. If you have a lower coupon rate, it means that you have actually smaller cash flows before that maturity date. That is, when you're having lower coupon rate, a lot of payments are pushed into this principal, right? However, you can see that if you push a lot of payments into principal, the weight of this further dated cash flows will be larger. This will actually increase your duration. Now, let's look at the third observation. Duration always increases with maturity for bonds selling at par or at premium to par. This is actually quite intuitive, right? Generally, you should expect if your bond has longer maturity, then duration should also increase, right? This is like the normal result. The surprising result is if the bond has a very deep discount, right? Let's say its coupon payment is much lower compared with the yield, then possibly, as maturity increases, the duration for this bond will actually decrease. So how do you see this from this picture? So here, you could basically look at this guy, right? The dashed line. If you look at the other coupon payments, if you look at the other coupon bond, you can see that duration increases as their maturity increases, right? Now, if you look at this 3% coupon bond, you can see that at a certain range, for this range, as maturity increases, this 3% coupon bond actually its duration decreases. And you can see that this is a deeply discounted coupon bond. The reason is because its coupon rate is only 3%, and its yield is 15%. So its coupon rate is much lower compared with its yield. So this has to be a deep discount bond. Fourth, the duration of a coupon bond is lower when the bond's YTM is higher. Now, how do you see this result here? So you could basically compare these two coupon bonds, right? And you can see that the bond with yield of 15% always has a lower duration, right? Okay. Let's look at the fifth result. A duration of a perpetuity is equal to 1 plus y divided by y. Right? Y, again, is the yield here. Y is the yield. Now, what is a perpetuity? It's just a bond which pays you this coupon payments forever. Right? Okay, now let's talk about convexity. Convexity is a more advanced concept, which is also related to how bond price changes with interest rate change. So first, you guys should be familiar with convexity, right? We have mentioned this before. That is, the relationship between bond price and yield is convex, right? Again, what is convex? So if a curve looks like this, it's convex. Right? This is convex. And if the curve looks like this, it's concave. It's just a mathematical definition. Now, what's the implication, right? Why do we care about convexity? Well, there are multiple reasons. The first reason is, let me first remove these two pictures. The first reason we care about convexity is if there is convexity in bound price, then the duration rule is just a good approximation, only there are small changes in bound yields. This basically talks about this. So when this will hold, this is only true. It's actually never true. It's only a good approximation, right? It's only a good approximation. If the change in yield is small, right? Obviously, this implies that if delta y is large, right? If delta y is large, this formula is not good. It's not a good approximation. Why? Why do we have this result? It's actually very easy to understand. So let me first draw out this formula, right? Let's say I am having a two-dimensional graph, and on this vertical axis, I am having delta P divided by P, that is bound price change. On the horizontal axis, I am having delta Y, that is the yield change, right? Let's say duration, let's say the modified duration equals to 1, right? So this tells us the percentage change in bound price equals minus delta Y. Now, if you draw out this formula, what you will get? You will get a straight line like this, right? The slope here is minus 1. So basically, you can see that if you draw out this formula, you will get a straight line, and the slope of this line is minus modified duration, right? Okay, now let's look at this example here. Let's say you have a 30-year maturity, 8% coupon rate, and yield 8%, initial yield of 8%. So we want to think about how the percentage change in bound price is related to the change in yield. Hey, we know that there is convexity in bound price. So we know that the actual price change, right? The actual price change should be convex. Right? So we should look at this line. This is the correct relationship. Now, what kind of result we can get if we use this formula here? And you guys just learned, if you draw out this formula, it is a straight line and its slope is minus modified duration. So if you draw out this formula, you will get this line, right? Now, both lines are talking about how the percentage change in bound price is related to the change in yield. And you can see that using duration, you're only getting some sort of approximation here, right? And you can see that it is only, and you can see that this approximation is only a good approximation if the yield change is small, right? Let's say the yield changes, right? So this is the original yield. Let's say it increases by 1%. Then you can see that these two lines, they almost overlap, right? This means the approximation here is good. Now let's say it increases by 5%, right? You're looking at 5%. Now you can see that the approximation line using duration has a large gap with the actual price change, right? You can see that this change is fairly large. It's almost 25% difference, right? So this would go back our result here. That is, duration rule is only a good approximation for small change. For large change, duration rule is not accurate. So that's why we need a more accurate formula, right? Now, how do you improve this formula? So you can see that now we're having this modified duration rule by adding a different term. We know that the original duration rule wasn't so accurate if yield change is large. The reason for that problem is because of convexity. So we could modify this by adding the convexity term here, right? So you can see that a more accurate formula is the change in bound price equals minus modified duration times the change in bound yield plus 1/2, right? Times convexity times change in yield squared. So for this formula, we basically have low requirement. For example, I will not ask you to calculate convexity because we have not formally defined or we have not shown you what is the formula for calculating convexity. So here you just need to know that there exists a more accurate formula to tell you how bound price changes with respect to the change in bound yield. Okay, so I guess my time is up. So that's for today's class.